Hello everyone, myself Harshita. Today my seminar topic is combinational logic circuits. About combinational logic circuits. Combinational logic circuits are digital circuits where the output depends only on the present inputs, not any past history or memory. In other words, they don't have storage elements like flip flops. Think of them like a vending machine without remembering your previous choices. You press a button as input and instantly the machine gives the corresponding item as output. Here the key features. No memory outputs are not affected by previous inputs. Output is equals to direct function of the inputs. Build using logic gates like AND, NOR, NOT, NAND, NOR, XOR, and XNOR. Here the examples of combinational logic circuits. Firstly, first example of combinational logic circuits are adders. Adders like half adder and full adder. Second one, subtractors. Third one, multipliers. Fourth one, demultipliers. Fifth one, encoders. Sixth one, decoders. And finally, seventh one, computators. Procedure of combinational logic circuits. Here the general design procedure. Design procedure for combinational logic circuits is step 1, problem definition. Understand the requirements of the circuit and identify the number of inputs and desired outputs. Second step, consider the truth table and list all the possible input combinations and also write the corresponding outputs of each case. Truth tables form the backbone of the design. Derive Boolean expressions. And step 3. From the truth table, write Boolean expression for each output using sum of minterms or product of max terms. Step 4. Simplify the Boolean expressions using algebraic simplification or K-maps to reduce the logic. This step minimizes the number of gates and complexity. Step 4. Implement with logic gates and draw the circuit diagram using basic gates as and or no and not or universal gates NAND and NOR. Choose ICs if needed. And sixth step is to verify the circuit. Recheck the truth table with your design and ensure the output matches the required specification. Example for combinational logic circuit. Here the example. Design of half adder. Firstly, problem is add two 1-bit members. And secondly, inputs are A and B. And finally we get as outputs sum and carry. Truth tables are, if we take A B as 0 0, then the sum will then the sum is 0 and carry is 1. If we take AB as 0, 1 and the sum is 1 and carry is 0. AB as 1, 0, then the sum is 1 and carry is 0. And finally, if we take A as 1 and B as B, then the sum is 0 and carry is 1. And fourth one, Boolean expressions. Sum is equals to A plus B and carry is equals to A into B. Simplify the already minimal. And finally, sixth one, implement. Use X or gate for sum and NAND and gate for carry. Classification of combinational logic circuits. Here the classification of combinational logic circuits. Firstly, we can discuss about arithmetic circuits. Arithmetic circuits performs on arithmetic operations like half adder, full adder, half subtractor, full subtractor, parallel adder, and subtractor. Arithmetic logic unit ALU. And second one, data rotating circuits. Data rotating circuits controls the flow of data, that is multiplexer and demultiplexer. Third one, code converter circuits. Code converter circuits are convert one form of code into another form. Here that binary code converter to gray code converter and gray binary code converter to BCD converters and BCD code converters to axis 3 converter and 7 segment display decoders. Fourth one, decoder circuits. Decoder circuits convert binary input into one active output, that is n2 to power n. Decoder, for example, 2 to 4 and 3 to 8 and 4 to 16. And final fifth one, encoder circuits. Encoder circuits performs the reverse of decoding, that is many inputs are binary codes like 8 to 3 encoders, decimal to BCD encoders, and priority encoders. And sixth one, computator circuits. Computator circuits are compare two numbers and indicate relation, that is 1-bit computator and 4-bit computator. In short, that we call as combinational circuits, arithmetic plus data rotating plus code conversions plus decoders plus encoders plus computators. Here the examples of combinational logic circuits in detail. One of the simplest but most important combinational logic circuits. Here the example that we are mostly important in combinational logic circuit is half adder. The definition of half adder is a half adder is a combinational circuit that adds two single bit binary numbers and provides two outputs. The outputs as sum S and carry C. And second one is inputs and outputs. Inputs as we take A and B. Each can be 0 or 1. And outputs we can take as sum S, that is A plus B. We use the gates as XOR gate, and carry we take as A into B. The gate is AND gate. Here the truth table of half adder. Here we take as A, B as inputs and sum and carry as outputs. Then the sum works like XOR, that is one only if inputs are different, and the carry is one only when both inputs are one. And fourth one, logic gates. We use logic gates as XOR gate for sum and NAND gate for carry. Here the applications for combinational logic gates. Combinational logic gates are basically used in binary addition inside the computers. Basis for building more complex circuits, like we know that full adder, arithmetic logic units, that is ALU, and etc. These are the applications for the combinational logic circuits. So this is a detailed example of a combinational logic circuit. Thank you.